What is up, guys? Welcome back to another video of mine. So today we're going to be doing some AP Physics C mechanics review problems, multiple choice problems, and these problems will specifically be kinematic ones. And we might include some circular motion as well. I haven't exactly looked at all of the problems to know what is on them, but I have an idea. Okay, so the first problem: an object that is moving with constant speed travels once around a circular path. Which of the following is/are true concerning this motion? I. So 1, the displacement is 0. 2, the average speed is 0. 3, the acceleration is 0. Well, let's see. We have a circular path. In fact, let me should have a circle here. Yeah, there we go. Oh no, that's an oval. All right, so that's weird. All right, well, anyway, I'm not sure why that's not working, but we'll figure it out later. So basically, you have a circle. You have an object traveling on a circular path, as shown. It makes the object makes one complete revolution, right? So it travels once around the path. So we know displacement is the final position minus the initial position. Well, the final position we can say is 0 or x. That's where it starts, and that's where it ends. So the change in position is 0. Therefore, the displacement is also 0, as that is what displacement is. It's the change in position. So we know that that I is true. So we could say this. Forgive me if I'm getting used to the drawing on this. Okay, so. Oh no, we know that, yeah, so we know that that's true. The displacement is 0. The average speed is 0. We know average speed is, so average speed, like that. It'll actually be what's it called? The absolute value of the average velocity is the average speed. And that is equal to the distance traveled, which is 2 pi r, right? And the initial 0, all over the period. And we know that this cannot be 0 because the numerator is a non-zero value. R is a value, therefore the numerator is a value, and t is also a value. So it is not equal to 0. Let's write this. Which means that, well, here it's saying the average speed is 0. It's not, so that's a false. And the third part is the acceleration is 0. Well, we know that the acceleration, if it has a constant speed, right, that means that its tangential acceleration, a sub t, must be 0. But we know that acceleration is a vector, which means it has both a tangential and a centripetal component. Has both. And it must have a centripetal component since the object is in circular motion, a sub c, which means that even though it does have an acceleration, the acceleration is not 0, which means that this statement is false. It's not true. So the only true one is A. So let me just do this. So the answer is A for the first one. Okay. So problem 2. At time t equals 1, an object's velocity is given by the vector v sub 1 shown below. It has no vertical component, we could say. A short time later, at t equals t sub 2, the object's velocity is the vector v sub 2. If v sub 2 equals v sub 1, which of the following vectors best illustrates the object's average acceleration between t1 and t2? Okay. So, well, what is average acceleration? Average acceleration, denote that by a, with a line over it, is equal to the change in velocity over a period of time divided by the change in time over that period. So we know that it's v2 minus v1 over t2 minus t1. Okay, so we know that t2 minus t1 is a scalar, so we can write that as a constant c. And in other words, the average acceleration is equal to 1 over c times a vector, right? A vector minus a vector is a vector. So we have vector 1, velocity, time sub 1, and then we have the vector 2, okay? So here's the thing. Vector 2 minus vector 1. We know in vector subtraction we can write this as vector 2 plus the opposite of vector 1. Right, so here, if vector 1's the opposite of vector 1, you change the sign, so it flips, and you have vector 2 remains constant. However, you're adding the two vectors now. So this is actually minus v sub 1, and to add the vectors, I'll write this red. So you connect the tail of negative v sub 1, or the head of negative v sub 1 to the tail of v sub 2, and you add the two vectors, and v sub 2 is your acceleration. And so that would be the numerator, right? But you're dividing by scalars, so that's the direction doesn't change. And if you look, which vector, this vector is, if you see it has to be C, because D's vector is closer to horizontal. It's closer to being parallel to v1 than the acceleration actually is. So the answer is C. Okay. So problem 3. A rock is thrown off of a 30-meter cliff at a 45-degree angle above the horizontal. Okay, so let's draw a picture to depict this situation. A cliff, okay. Right, so it's thrown at so the cliff is 30 meters. So we can write 30. And it's thrown at 45 degrees above horizontal. Drawing a dotted line here. So that's the initial velocity vector, and you have 45-degree angle above horizontal. So now keep in mind, these problems might take longer for me to solve simply because I'm drawing on this whiteboard, but so in person it should take less time. So which of the following is true regarding the acceleration of the rock? A, the acceleration will be of magnitude g and have both horizontal and vertical components. We know that this is not true because the horizontal velocity remains constant, which therefore there is no horizontal acceleration. So it does not have a horizontal component, so that's false. B, at the peak of the rock's path, the magnitude of the acceleration will be half of what it was when the rock was initially thrown. Again, we know that g remains constant, so that's not true. The acceleration will be of magnitude g and in a downward direction. We know that that is true. So C must be true. D, we'll look at the other two. The acceleration will be downward during the rock's ascent and upward during the rock's descent. No, that's not true. Because the rock will, we know that the acceleration, we know that the acceleration is constant, and we also know that its direction does not change. So C, and then E, the acceleration will increase throughout. Nope. So it's C. Okay, that's the only one that's true. Okay. Question 4. A baseball is thrown straight upward. What is the ball's acceleration at its highest point? The acceleration at its highest point is still g downward. Okay, we know that its vertical velocity, which in this case is its only velocity because it doesn't have a horizontal one, is 0 at its maximum point or at the peak. However, it must have a downward acceleration or else it wouldn't come down. It would stay up in the air. Right? So logically, we know that the acceleration, it must have a acceleration. Okay. And it must be downward or else the ball would accelerate upward past its maximum point, which doesn't make sense because then it wouldn't be its maximum point. Okay, so an object's location in meters after t seconds have passed is given by the equation x of t equals negative 3t cubed plus t squared plus 6t. What is the maximum velocity of the object? Okay, well first, to find the velocity, we know the velocity is the derivative of position. So we know that velocity is equal to negative 9t squared plus 2t plus 6. Now, what we could do is you could use quadratic formula, find the zeros, find the center between the two zeros, plug that t value back in the equation, and find your maximum. Or, which would also be your vertex, in this case, because the parabola is concave down, it opens downward. So, you could do that, or you could realize that at the maximum velocity, the acceleration will be 0. Right? What is the maximum velocity? Because, if we look at the velocity function, a maximum velocity will look like this. And this will be the maximum. And if you take the derivative at this point, which is be the acceleration at this point, it has to be 0. So, we take the derivative of the velocity function to get the acceleration function. That's negative 18t plus 2. Set it equal to 0. And you get negative 2 divided by negative 18, which is 1/9, which is equal to the time at which the object reaches maximum velocity. And it's not, but be careful. Don't choose A. That's the time. in seconds. You want the velocity. So if you want the velocity at 1/9 seconds, which is maybe I should have brought a calculator. I'll just is 6 point so it's 6.11. So the answer is C. Okay, so fairly easy question compared to the others. Number 6, a rock is dropped off a cliff and strikes the ground with an impact speed of 30 meters per second. How high was the cliff? A rock was dropped, so let's depict this situation. Okay. So, let's assume that if it was dropped, it wasn't thrown. And basically, that implies that its initial and final horizontal velocity is 0. Why? Because its initial, it doesn't have an initial horizontal velocity. It's simply falling towards the earth. Okay. And it doesn't even have to, if it's dropped, right? Imagine someone's holding it over here. If it's dropped, then it has 0 initial, what's it called? So an initial vertical velocity, right? Because it doesn't say it's being thrown down toward the earth. It says it's being dropped, and it has no horizontal, nor does it have a final horizontal velocity. So how high was the cliff? Well, we can use our kinematic equations that has position. So we know that let's call this starting point. So that the height of the cliff -x, because downward will be negative. And let's say that this position, the top of the cliff, is actually x initial, which is 0. Okay. So we know that the final vertical velocity is actually 30 meters per second. And we know that the acceleration due to gravity is equal to -9.8 meters per second squared. So we can use, and we're solving for the final, right? Which we could just call x, because we don't, the negative, it already have a negative in the equation. So we could say x, which is the final position, which is the height of the cliff. And that's actually in the y direction, so it's y. It's the y. Okay, so we could say y equals -1/2 gt squared. We don't know the time, so why don't we use what's it called? We'll use the third kinematic equation on the formula sheet instead. Right, so we'll use Vy squared, so that's just the final velocity, or final vertical velocity, is equal to Vy's initial squared plus two, oh, it's actually minus 2g y, and then minus 0. Let's write the initial y displacement is 0. So now you can actually solve for y, because we know that this is 900. We know that the initial y velocity is 0. And let's divide by, see, I don't know if they want us to use exact. So you could use a calculator, or you could realize that you could round g to negative 10, and this would be 20. So you're really dividing by 20, and that's approximately the height of the cliff, which is 45. So the answer is D. Now, of course, like I said, it's taking a while because I would do these quicker if I, so maybe it would take like 2/3 of the time that this video is taking right now. We'll do this last problem, and then I'll do a part 2 finishing these problems. So, okay, problem 7.